In this section, we're going to look at basic exponent principles within algebra. Now with that said, imagine your favorite superhero. But this time, imagine the heroes being numbers. The superheroes are your constants or unknown variables. They are also called the base. Exponents are the little number at the upper right corner of the base. Pretend that they represent the power level of the superhero. The higher the exponent number, the higher the power level. The power increases when the base multiplies with itself, and therefore the exponent number tells you the exact number of times the base has multiplied itself. You might be saying, that's fine and all, but why is this important? Well, because exponents have their own set of rules that apply even in algebra. Knowing these rules can save you a whole lot of time and headache when you have to solve or simplify scary-looking expressions that have exponents. So let's look into these exponent rules. Rule 1. When multiplying with the same base, you add the exponents. Think of it as a power-up. This here is your base having an increase in power the more it multiplies with itself. So the overall formula is such: a with an exponent of m multiplied by a with an exponent of n equals a with the power of m plus n. For example, let's say we want to know a times a to the power of 2. Remember, the one exponent is invisible, but it's there. So a to the power of 1 times a to the power of 2 equals a to the power of 1 plus 2. Therefore, a to the power of 3 is the answer. The same would apply with a constant. We have 3 to the power of 2 times 3 to the power of 3. That means 3 is to the power of 2 plus 3, which is 3 to the power of 5. Rule 2. When dividing with the same base, we subtract the exponents. Think of this as powering down. The overall formula for Rule 2 is a to the exponent of m divided by a to the exponent of n, which is equal to a to the exponent of m minus n. Typically, when dividing in algebra, the expression is written as a fraction. Rarely do you see the division sign. So, using Rule 2 for this example here, we have 6 to the power of 10 divided by 6 to the power of 8, which is equal to 6 to the power of 10 minus 8, which is equal to 6 to the power of 2, or 36. Let's look at this applied to an unknown variable. We have y to the power of 4 divided by y to the power of 3. This is equal to y to the power of 4 minus 3, which is equal to y to the power of 1, or just y. Rule 3. Power of a power. As the title suggests, your base has a power, but this time the power is supercharged with another power. In this case, you multiply both exponents. The formula for Rule 3 is a to the power of m all to the power of n, meaning that a is to the power of m times n. Let's take a look at x squared to the power of 3. X squared to the power of 3 is really x to the power of 2 times 3, which is equal to x to the power of 6. Whenever you see a value in brackets followed by an exponent, that means the entire value in the brackets is the base. So the case of x squared to the power of 3, x squared is the base multiplying itself 3 times. Written out, it looks like this: x squared times x squared times x squared. Since we're multiplying by the same base, we add the exponents to get x to the power of 2 plus 2 plus 2, which is equal to x to the power of 6. With Rule 3, simply multiplying the exponents will give you the same answer. Now let's say we have y to the power of 4 all to the power of 10. with y to the power of 4 as the base. The last thing you want to do is write out y to the 4 10 times, then add all 4s. Save time and just multiply the exponents instead to get y to the power of 4 times 10, which is y to the power of 40. Rule 4. Power of a product. Let's briefly recall what a product is in math. It's simply the result of two or more numbers and or variables being multiplied, such as xy or 3x. What this rule means is, if the base inside the brackets is a product, then both the numbers get the power. Think of it as a superhero team working together to power up at the same time. The formula for Rule 4 is a times b to the power of m is equal to a to the power of m times b to the power of m. With the expression 3y to the power of 3, what it means is 3 times y to the power of 3. Therefore, both the number 3 and the letter y are to the power of 3, meaning the answer is 27 times y to the power of 3. If we write it out the long way, here's what it looks like. 3y times 3y times 3y. Now let's look at this expression. 6 times a times b, all to the power of 2. Even though there are 3 values that are a product, the rule stays the same. This team of values all get the power of 2. So 6 times a times b to the power of 2 becomes 6 squared times a squared times b squared. Therefore, simplified, the answer is 36 times a squared times b squared. Rule 5. The zero exponent rule. Lastly, this is the easiest but least exciting of the rules. Simply put, any value or number except 0 with the power of 0 turns into 1. Think of our heroes taking a nap. So as an example, 5 to the power of 3 divided by 5 to the power of 3 would be 5 to the power of 3 minus 3, which is equal to 5 to the 0. Makes sense because a number divided by itself always equals 1. Alright, now that you know the exponent rules, let's see where they apply with simplifying this expression. It might look a bit crazy, but it's not as bad as you might think. In math, the first step is to always deal with the fun that's happening inside the brackets. We see the base variable x, which is to the power of 3, being divided by itself, which is x to the power of 1. So based off of Rule 2, we can subtract the exponent 1 from 3. Therefore, the x variable becomes x to the power of 2. Now we also have a y base, that is to the power of 2, being divided by y to the power of 1. Using Rule 2 again, we do the same thing and subtract exponent 1 from exponent 2. Therefore, y squared divided by y is equal to y to the power of 2 minus 1, which is equal to y. Okay, now that we've divided all the fun in the brackets, we get x squared times y to the power of 4. Now we apply the power of a product rule, which is Rule 4, and distribute the exponent 4 to both bases. So x squared times y to the power of 4 becomes x squared to the power of 4 times y to the power of 4. Now using Rule 3, we apply the power of a power rule by multiplying the exponents. So that's x to the power of 2 times 4 multiplied by y to the power of 1 times 4. This results in a final answer of x to the power of 8 times y to the power of 4. And there you have it. Using these 5 rules is a must if you're ever requested to simplify an expression with a lot of powers. Well, that's a wrap. Now get to studying.